And I am trying to post those. For whatever reason, I don't know what the problem is, but I've had some trouble just straight uploading them into Canvas the last couple of days. But I am able to put them on YouTube, and so I'm posting the YouTube links on Canvas where it says video lectures. So hopefully, I had several people in the spring who that worked better for anyway. They were just, for whatever reason, they were able to watch them better on YouTube than they could through Canvas. So just know that I am trying to do that so that you can go in. And once you find that, I'm not real familiar with YouTube, so somebody feel free to correct me. My children would correct me. I think though that once you find that channel or that place where I've saved all the intermediate algebra videos, you don't necessarily have to go through Canvas. You can just go straight to YouTube to view them. Because I made them public. Not that anybody else wants to watch these videos, but it's okay. You can watch them as many times as you want to, and pause me and rewind and all kinds of things. So anyway, stop me, mute me, whatever you'd like to do. So it's kind of like even better than having me write in class, because you can't mute me in class. Sorry. Anyway, so hopefully those are being helpful. So today we're going to be working on factoring polynomials. Yesterday, what we did was we multiplied these things together, and today we're going to be factoring. We're going to talk about several different techniques for factoring polynomials, and I am really going to try to get you guys involved in this. So be prepared to either type me answers in chats or to answer me verbally. You're welcome to send me, when I ask you for input, you're welcome to send it to me privately to me, or you can answer to everyone. Just change that where it says chat, just change the to me instead of everyone. But I do really want to, because I'm going to tell you right now, I can factor all day long. I have been doing this for a really long time, and so I'm actually relatively good at it most of the time. But you guys are the ones who need practice. So I have discovered that when I teach factoring, I try to make you do as much as possible, because me just sitting there giving you the answers to everything is really not helping you out. So I'm going to be calling on some people, and sometimes I'm going to say, everybody put me an answer on here. And sometimes I'm going to call on individuals. So just beware and know that that's coming. If you don't answer me, I will not be happy. And so bad things may happen to you. So don't disappear on me, and make sure that that you answer. So Nico, I did see you come in. I don't think Chelsea, Hannah, Raven, and Brianna. If any of you are here, please let me know. Okay. All right. So like I said, we're going to be talking about factoring. And so there's a bunch of words on this page. So we're going to kind of go through this. Hopefully, even if you don't print everything else out, you can print out sometimes just having these like screens that have the words and stuff, or go into the Canvas and just make sure that you're writing out some of these things. So, okay, perfect. Okay, so when we talk about factoring, and I'm going to scroll down so you can see all of this, and we'll come back and refer back to this. The first thing we look for when we factor is to factor out what's called the greatest common factor. And this is going to be the largest number that divides everything, and it's actually going to be, it's the smallest exponent, so that's shared. And so let me kind of remind you with numbers about factoring. So if I had something like the number 24, let's say, okay, and this doesn't have to do with polynomials, but when we talk about factoring, factoring is just dividing, all right? So if I said, well, we want to factor 24, okay, so you maybe want to factor 24 into 2 times 12. Those would be factors of 24, okay? There are other factors of 24. Need to do this real quick. Okay, there are other factors of 24. We could say that 24 is
he was way hard.
Yeah, artillery.
He got a bucket full of bullets, nigga. He's steady, nigga. They got to reload. They clip empty. It's over with.
I'm just thinking I find that bitch, boy.
I'm talking about nigga. They got there high behind the corner. He shooting for the wall.
I'll just mute him.
God out there.
Oh,
I keep trying to mute you.
I get my bracelet.
Hey, Bill, Steve, y'all boys, shut up over there, bro.
Okay, I am so glad that everybody is here, but I don't need all of your background friends to join us also. So, okay, I think we're all muted now and we're all good. But I'm glad that y'all are here. So anyway, back to factoring. Okay, so we can factor 24 into 2 times 12 or 3 times 8. We can factor 24 into 2 times 2 times 2 times 3. And this is what we call a product of primes. And that is ultimately what we're trying to do when we factor polynomials. We're trying to get it into the smallest possible factors we can. If I were to come along and say, hey, 24, 4 is a factor of 24. What is the other factor? And you would say, oh, 24 divided by 4, that's 6. So when we factor, we're actually dividing, okay? And so that was the whole point of this exercise that kind of got interrupted, but it's okay. All right, so we're going to, first thing we always look for when we factor polynomials is a greatest common factor. The second thing we do is we count the number of terms we want to factor. Do we want to factor 4 terms? Then we're going to use something called grouping. Do we want to factor 3 terms? Well, here we're actually going to unfoil rather than foil, because when we foiled, we put them together, and now we're going to take them apart, okay? If we only have 2 terms, then there are some formulas that we are very likely going to use, okay? And those formulas are the difference of 2 squares, the difference of 2 cubes, and the sum of 2 cubes, because all 3 of these only have 2 terms. And so when we get to those problems, I will write these formulas again for you, but I just like to put it all on one page just so that you have something to kind of refer back to. So we're always going to look for a greatest common factor. Then we're going to look for how many terms we have. 4 is going to use grouping. 3 is going to be unfoiling. There's some other little techniques in there that we can use. And then 2 terms is going to be one of our 3 formulas. So let's kick this off and get started. Okay, so number 1 up here, I have 8s cubed plus 4s. Okay, first things first, I have 2 terms, okay? And I am always going to look for that greatest common factor. No matter what's going on, I'm going to look for that greatest common factor. So I'm going to help you out with this one. And the next one we're going to do together, and you're actually going to do some work for me. So when I look for the greatest common factor, I look for the largest number that happens to be common to both of these. And so I have 2 terms, and I'm looking for a greatest common factor. I see 8 and I see 4. Now, this is not the same thing as the least common denominator or least common multiple. This is the greatest common factor. So it's actually going to be the smallest of the 2 numbers, as long as they both divide in. So I look at 4 and I say 4 divides into 8. So 4 is my greatest common number factor. Then I look at s to the third and s to the first, and s to the first is my greatest common variable factor. So just like with 24, when I said if 4 divides into 24, what's left? Well, that's what we're going to be doing when we factor. So when we take out that greatest common factor, we write it in front. We take each term and divide it by 4s. Now, I am not ever going to do what I'm about to do ever again, but I am going to do it on this problem. So to get what's in here, I'm going to take 8s to the third, and I'm going to divide by 4s. And I'm going to take 4s, and I'm going to divide it by 4s. Remember, the very last thing we did yesterday was to divide polynomials. And that's essentially what I'm doing here. I'm taking my polynomial of 8s cubed plus 4s, and I'm dividing it by my greatest common factor. Now, this is part of my answer, so that when I say I'm going to have my factors, I have to keep my greatest common factor, but I'm dividing each term by that. So here, my 8 divided by 4 is 2, and s to the third divided by s is s squared. And then I have plus and 4s divided by 4s is 1. And so my final answer here in factored form, and these directions should say up here, factor completely. I don't know how I managed to get a page without directions. Factor completely, okay? So this is my factored form, okay? How do I know I'm right? Does anybody know how to check this? Can anybody tell me how I might check this to see if I'm correct? I'm open to suggestions. You can either type them or say them. How would I check this?
Distribute the 4s.
Exactly. So I would go through and I would say, okay, I'm going to take 4s times 2s squared plus 1, and I would distribute the 4s through there. So that would give me 8s to the third plus, and then this is going to give me 4s, and it is exactly what I started with, okay? So this is my little check bubble over here. You can always check factors. Okay, let me say that again. Don't miss these. You can always check factors, okay? So please be very, very careful on these, right? Always check them. I may not always check them for you right here, but you can always check them. Okay, so number 2 is also got a greatest common factor. And I'm going to give you a hint. It has a greatest common number. It has a greatest common variable m and a greatest common n variable. So I want everybody to figure out what the greatest common factor is, and I want you to put it in the chat to me. You can do it privately or you can do it to everybody, but I want to know what the greatest common factor is. So I want you to tell me what I'm going to take out of this polynomial. So hard to be the first one, but you may not be the first one. Send it to me individually, you'll never ever know. I got a number, I got a letter, and I got another letter. So look and see what's common. Got an 8 and a 72. If you get it wrong, I promise I will ask one. I won't even throw anything at you. I know you're out there.
You asked for Brandon.
I'm asking anybody, Brandon. You got an answer for me? You can even say, I don't know. That's an acceptable answer. I just need to know you're out there listening to me. I feel like I'm talking to myself. I know this one's a hard one.
Negative 8m 4 power n 4 power parentheses n plus 9 close parentheses.
Okay, well, hang on. Slow down. Slow down. So negative 8. And what's
Yeah,
my m to a power?
Yeah, man.
M to what power?
4.
M to the 4th and n to the
4.
4th. Okay, why'd you pick 4 and not 5?
Shit, that's how I worked it out. That's how it came to.
That's how it came to you? Okay, so let's think about this and see if we can figure out how it came to you, okay? If I put 5 here, right?
Yeah.
Would 5 divide into 4?
Nah.
No, it's too big.
Yo, that's
Okay,
why it's 4.
there you go. Okay,
I know
so
that stuff.
okay, Well, we just got to put it into words. So I know sometimes we just know things and we're got to put them into words. Okay.
Yeah.
Okay, perfect. Okay, so hopefully everybody looked at this. Some of you probably put +8, and there's nothing wrong with that, except that since both of them do have a negative, Brandon was correct in that I want to take out a -8. Okay, since both of them are negative, I want to take out that negative. M to the fourth, well, they both have an M to the fourth. This one had an M to the fifth, but I need to make sure it's the smallest exponent, because then the next step in this is to say, okay, what's left? And this is where I'm going to go through this process of I'm going to take each piece and divide it by that -8m to the fourth n to the fourth. Okay, Brandon, I know you had the rest of this, so help me out here. What am I left with in this first term?
You got the n, the n. I mean, not the n, the 9, the n plus 9.
N, and then it's a plus, and then just my 9. Yep.
Yes, ma'am.
And so here, because I had n to the fifth, that n to the fourth just left me with an n to the first. -72 divided by -8 gives me a +9, and everything else divided out. And so this then is my final answer. Okay. All right. And I know everybody else is not asleep. So you're going to answer my next one, because otherwise I'm going to have to start calling on you. So, Brandon, you're safe for just a little bit. I won't call on you just yet, since you voluntarily answered, kind of, sort of.
Excuse me, Walter. This one's super easy though. This one gonna be W, open parentheses, W plus X, close parentheses, open parentheses,
Slow down, Brandon. Brandon,
close
Brandon,
parentheses.
Brandon,
Huh?
slow down just a tiny bit.
Oh my bad, I talk too fast.
It's okay. No, it's okay. I just need to tell everybody else something real quick. I'm so glad you're here and participating, though. I really am. Okay.
Yeah, man.
What I need you all to look for, though, first of all, is there, because Brandon saw there's some greatest common factors, but is there a greatest common factor to all 4 terms? And the answer is no, there's not. There's something common to the first 2, there's something common to the last 2, but there is not a single factor common to all 4 terms. So for this reason, we can't use just the greatest common factor. And so now I need you to look and see that there are actually 4 terms here. So there's 1, 2, 3, 4. And if you go back to the previous page, 4 terms means we factor by grouping. And that's where he was talking about we factor this out of this and this out of this, and then this is what we're left with. So when we factor by grouping with our 4 terms, we always look to group the first 2 terms together, and then we're going to look at the second 2 terms, okay? So as I look at the first 2, what was my common factor for these first 2 terms? Can somebody tell me what just the common factor is for the first 2 terms?
V.
V, exactly. So V is my common factor for the first 2 terms, and then that's going to leave me with a W plus X, okay? And that's big, all right? So who can tell me what my factors for the second 2 terms are? Factor, just one of them. In other words, what's common to these 2 terms? And a V common to the first 2, what's common to the second 2?
K.
Okay, exactly. And then that's going to leave me with W plus X. Now, here's where we have to be really careful, because now we've got to do a second greatest common factor thing. So we looked at the 2 terms and we looked at the second 2 terms, found a common factor to both of those. If you do this correctly, so here we are factor by grouping. So we are using grouping because we have 4 terms. If you've done this correctly, now you should have a common parentheses. And when I take out that common parentheses, I take out this W plus X. And what I'm left with is I'm left with a V in the first term and a plus K in the second term. And so this is my final answer. And that's where you were headed. Let go, Brandon. Okay. Questions? This is a little bit strange and different. Some people have seen this method before and some people have not. Okay, so if you've never seen this before, it's not the end of the world. It is kind of a nice little technique, and it does typically work for our problems that have 4 terms in them. All right. Again, we look for a greatest common factor. All of these problems with directions are the same. They're all going to be factor problems. So as we get ready to factor this next set, we look for something common to all 3 terms. Well, these first 3 have a 2. The second 2 have an 11. So there's nothing common to all 4 terms, and that's the problem. So I do have 4 terms. So I'm going to look to factor by grouping. Okay. I'm going to call on somebody in just a second. I want you to look at the first 2 terms, and I want you to look at the second 2 terms. All right. And I want you to figure out what the greatest common factor for the first 2 terms is. And I'm going to pick a random person to call on, and you can either chat to me or you can tell me. If you're wrong, it's okay. I promise there's no horrible thing that's going to happen to you. Greatest common factor for 4 and negative 2x. Let's go with Aaliyah. You can either chat it to me or you can tell me what you think the greatest common factor for these 2 terms is. Aaliyah. Kind of beginning to think I got some folks who gone and pushed on me. Aaliyah, are you here? Maybe not. All right, we'll try somebody else. Reese. You help me out.
For the first one, it's 2.
It's 2, exactly. So if I take a 2 out of these 2 terms, what's that going to leave me with?
2 minus x.
2 minus x, exactly. That's perfect. Excellent. Okay. All right. So let's see, Madison, I see you. Tell me what my greatest common factor for the second 2 terms is.
11.
Okay, 11. Now, but here's where I want to be careful, and that you said exactly what I wanted you to say. Look at it, 22 and 11. I would say 11 is a common term, okay? But look at the fact that this is negative and this one's positive. And I really want the second term to be negative and the first one to be positive. So I'm actually going to take out a negative 11. Madison, do you see anything else that's common to these 2 terms?
The y.
The y, exactly. Okay, perfect. That's exactly what I needed you to find. So most of the time we look to factor out that positive, but if the signs are not in the same order as they are in the first 2, we want to take a negative out. Okay, and so that's then going to leave me with negative 22y divided by negative 11y is going to be a positive 2. Negative 11, positive 11 divided by negative 11 is going to leave me with a negative. The y's divide out, and I have minus x. Okay, excellent. That's exactly what I needed. So now my greatest common factor to these 2 is 2x minus 2. I can't talk. 2 minus x. What I'm left with in the first term is a 2. And what I'm left with in the second term is a negative 11y. Okay. And this is my greatest common factor. Right? Questions? Okay. Now let's see if y'all are paying attention. Okay. So we're going to go.
Miss
Yes.
Walters,
Yes.
can you see the conversation with everyone? Because Nico said something. He asked a question. He said, "How did you get -11?"
Oh, I couldn't see it. I'm so glad you said that because it's all disappeared. Oh, wow. There's okay. So I can't fuss at y'all because you have actually been talking to me and I could absolutely not see any of that. It all disappeared on me. Thank you. See, this is why I need like a monitor. Y'all are so awesome. I was thinking y'all disappeared on me. Okay, hang on. Let's go back. Let's find this. Wow, that's crazy that it all disappeared. Okay. Yeah, I'm not seeing your chat. I see that now. Okay. But somebody, okay. Aaliyah, can you see the screen now? Yes. Okay, excellent. All right, very good. All right, we're all just, it's like a Monday. Is it a Monday? I think it's a Monday. Okay, so let's see. Where did I get the -11? Okay, I'm back. Let's go back here. Okay. Hmm. Okay, so we're gonna come back to this one. So I'm looking at my number. Are you asking me why it's negative or why it's 11? I can see the chat now. Why it's -11. Okay, so when I look at my two numbers here, so if I was just looking to factor -22y plus 11xy, and that was all my directions were to factor this, okay? I would look at these two numbers first and I would say, okay, 22 and 11 have a common factor of 11, okay? And then I have a common factor of y. And so if I took out that 11y, it would leave me -22 divided by a +11 would give me a -2 and then plus x. All right, does that make sense so far so good? Okay, so because though my first two terms left me with a factor of 2 minus x, I know, and I know you don't, but I know that I don't need to have a -2 plus x. I need this to be 2 minus x. And so that's what told me that I needed this -11 to come out. I needed to factor that negative out in addition to the 11. How are you supposed to know that? Because that's my guess is you're going, yeah, how was I supposed to know that? So my general rule is that if this sign on the third term is negative, factor a negative out, okay? So if the sign, when you look at the second two terms, when you look at that second pair of terms to get ready to factor, when that's negative, I'm going to factor a negative out, all right? Does that make a little bit of sense? Because I'm gonna show you the same kind of thing in the next one, and hopefully it'll sink in a little bit. Okay. All right, so let's look at number 5 down here, okay? And anybody, oh, okay. Oh, I'm so sorry. All right. Yeah, that's yeah, all you can see is the numbers. Okay. That's so not cool. All right. All right. Okay, and if somebody else wants to like translate and like tell me what I've said. Oh, okay, all right, okay. So let's look at and I actually think this might actually help a little bit. The next part, and so hopefully we'll kind of write through this. What I'm looking for here is my greatest common factor. So somebody tell me what the greatest common, because once again, I don't have anything common to all four of these. So let's talk about the first two and the second two. So common factors for the first two terms, and I can see the chat now. somebody tell me verbally or in the chat what the common factor for these first two terms is. And this one's a little bit tricky. There is a 2, okay? But is there something more than a 2 that's common to both of these? Oh, never mind, it's not. Don't listen to me. I've obviously lost my mind. So 2, is there something else that's common to both of these? A T, exactly. So a 2 and a T, okay? So that's going to leave me with, so I'm going to have my 2T is going to divide into 4ST, and that's going to give me a 2S, okay? 10T divided by 2T is going to be plus 5. Okay? Now, here's where, all right, here's where I need to see if you were just listening to me or if that made a sense. What sign is my third term? It's negative. And so I'm going to take out a negative, and it's going to be a negative 5, exactly. So I'm going to take out a negative 5 from the second 2, okay? And when I take that out, it's going to leave me with a 2s. Negative 25 divided by is a plus 5. And that's what I had in my first parentheses. And so hopefully that makes sense in terms of how do I know when to factor out that negative and how do I know when to not factor out that negative. Most of the time, I would say 95% of the problems that we're going to look at, if the third term is negative, we want to take a negative out. Okay. So now my greatest common factor is 2s plus 5. And that leaves me with 2t minus 5. And that is my factors. Questions? That was a hard one. Okay. So, in case the sound is still out, questions? I can't believe I couldn't see the chat. I wondered, I thought y'all just saw this. Oh, it's a day. It's okay. Okay, so why did I put the minus 5? Oh, that's actually, I have no idea why I put a minus 5. Yeah, no, never mind. Okay, I've lost my mind too. So no. So I put the minus 5 was because I took out this. You talking about this minus 5 right here? I hope. Okay. So I factored out my 2s plus this one. Yeah. Why is this one negative? Okay. So this one is negative because I factored out my 2s plus 5. So what I was left with. Think about, I don't like to do this, but think about I'm canceling this part out, and so I'm left with the 2t, and then I canceled this part out, and I was left with the negative 5. And so my 2s plus 5 is my greatest common factor here, and then that negative 5 is what I was left with in the second part. Does that make sense? I got several people who are asking me questions on the side, so. Okay, perfect, excellent. Okay. As long as I can see the chat, life is great. Okay. All right, other questions? Okay, all right, fabulous. If I need to go back, we can go back. Okay, so here's what I call sometimes, this was unfoil was on the list, but sometimes I just simply call it trial and error. So we're actually undoing things. And so I'm going to show you a couple of things. First of all, there's no greatest common factor, and I do have the 3 terms, okay? So because I have the 3 terms, I'm looking to factor these. Backtrack for just a minute with me, and this is backtrack. So we're going to call this backtrack. And so when we backtrack, yesterday, we talked about multiplying. We might have taken x plus 4 times x plus 7, okay? And when I multiplied these together, I got x squared. I got 7x plus 4x plus 28. And then these two guys came together to simplify to give me x squared plus 12x. No, let's try plus 11x. I can't add this one. Plus 11x plus 28. Okay. This is a trinomial. Okay. So today we're going to take these trinomials and we're going to undo them. Okay. Unmultiply them, unfoil them, whatever you want to call it. So there is no greatest common factor, not factoring by grouping. I am undoing this to come up with two binomials that give me this trinomial when I multiply. And so what I'm always looking for, and you might remember doing this from before, when I multiply the first two terms, I get the first term. So what that tells me is that over here, when I'm looking to do this, I need two things that give me s squared. Well, that would be an s and an s. Okay. When I multiply these together, my last term here comes from the product of my last term. So if I'm foiling, it comes from the last product. So 4 times 7 in this case was 28. I need two numbers whose product is negative 32. Okay, so I'm going to list those numbers over here. So I need the product of negative 32. Well, some numbers might be 4 and negative 8, but I could also use negative 4 and positive 8. I could use 2 and negative 16. I could use negative 2 and positive 16. I'm listing the factors that give me negative 32. Notice one sign is positive and one sign is negative to get a negative at the end, right? Okay. Where did I get the middle term from? The middle term comes from the outside inside product, okay? So the outside inside adds together to give me this. And so that means that these two numbers, 4 and 7 in this case, added together to give me 11. Which of these pairs adds together to give me positive 4? So we want to add these pairs, okay? And so if I add 4 plus negative 8, I get negative 4. And that's not what I want. I want positive 4. If I add negative 4 plus 8, I get positive 4. That's what I want, all right? And so that means that I'm going to have s minus 4 and s plus 8. Does that make sense? Questions? It's kind of some magic stuff. Right? Are we good? Think y'all can do the next one? Okay. All right. So same thing. Two things that multiply together to give me B. I'm going to help you out, are a B and a B. I need somebody to tell me what my second two numbers are. Multiply together to give me 10 and add together to give me 7. Chat it to me, say it. Yep, it is going to be. And notice that they're both plus. Okay, so she listed two positives. So positive 5 and positive 2. I got several answers there. Excellent. Does it matter what order I put them in? Absolutely not. Okay, it could be B plus 2 and B plus 5. That's fine. It's going to get me the same result. Okay, so these are my factors. Again, I could go over to the side and I could check them. Box in this one up, box in this one up, multiply it out, and I'm going to get this term to this polynomial. Okay, excellent. All right. So the next one's a little bit different because I've got some C's and some F's in there, making it a little bit stranger. The only real difference, though, you're going to see is that I am going to have a C and a C. And in order to get F squared at the end, I have to have an F and an F. And that's going to give me C times F in the middle. So now what I need is numbers that multiply together to give me negative 63 that add together to give me negative 2. Okay? So I'm going to give you just a couple of minutes to figure out what those are. And you can chat them to me, or you can yell them out, or whatever works. But I need negative 63 as my product and a negative 2 as my sum. Open to suggestion. Yes. So, excellent. Very good. And it doesn't matter which one I put first and which one I put second, as long as the negative goes with the 9 and the positive goes with the 7, okay? Because that product of negative 9 and positive 7 gives me negative 63, but I need the sum to be negative 2. Okay. Excellent. Questions, questions, questions. All right. Factoring is huge, and you're going to keep factoring and keep factoring and keep factoring. And factoring is one of the things that you're going to use in algebra. And factoring is one of the things that you would use in business calculus. And factoring is even something that you use in trig. So the only ones of you who probably will never see factoring after college algebra are those people who are going to take statistics next. Yeah, they don't do any factoring. I'm not sure what they know. They do some fabulous stuff, but it's just not like this. So, okay. All right. So let's rock on into the next ones. Okay. So in this problem, so I'm going to do, trying to decide. Yeah, we're going to use a little method that kind of combines the last stuff and some new stuff. So one thing we can do is we can use trial and error on this. One of the things I want you to notice, it is 3 terms, but there's no greatest common factor. And the same thing is going to apply down here to number 10. So these are going to kind of go together. What makes these problems different than the previous problems is there's a number that's not 1 in front of x squared. Now, some of you probably remember factoring from before, and most students, this is their least favorite way to factor because it just takes so much guessing, okay? So I'm going to show you a method that I actually learned relatively recently in the grand scheme of things, and because I had just always done trial and error. And somebody showed me this, and I was like, hey, that's really cool. I like that. So I'm going to show my students that. And some of them were like, I already knew how to do that. And I was like, that's kind of cool. My children were like, Mama, that's old. And I was like, well, that's okay. I am too. So anyway, they're like, we know how to do that. Like, whatever. So sometimes I learn new things. It's okay. So I'm going to show you what's called, somebody told me it was called the bottoms up method. And what we do on this is we need to figure out the factors of this, but it's kind of this little funky way to do things. We're going to take this number and we're going to multiply it times the end here. So I'm going to rewrite this into x squared plus 8x plus 16. Now, based on what we just got through doing, you guys know how to factor x squared plus 8x plus 16 because you got pretty good at that a while ago. So this is going to factor an x and an x and a plus and a plus and a 4 and a 4. Because 4 times 4 is 16 and 4 plus 4 is 8. That's amazing. But here's the catch. If I multiply these two together, I don't get 16x squared. So somehow I got to get a 16 or something in the front. So here's how this works. You multiply times the end and you factor this very nice polynomial. Now, whatever it is that I multiply by, I'm going to turn around and I'm going to divide by that. I know it's a little bit weird. And then I'm going to simplify this. So I have x plus 1/4 and x plus 1/4. If I have a fraction here, I'm going to take this denominator and I'm going to multiply it times the x. Whooshy whoosh. And my factors become 4x plus 1 times 4x plus 1. And those, my friends, are the factors for this polynomial. If I multiply this back out, I can check it over here. I check in blue, not in pink. If I check by taking 4x plus 1 times 4x plus 1, I do indeed get 16x squared plus 4x plus 4x plus 1, which gives me 8x in the middle. I think it's kind of cool and magical. Questions? Open to questions. Okay, has anybody ever seen that before? Or is this brand spanking new? Cool. Do you like it? I'm just curious. Okay, you don't have to like factoring to like this way. Okay. I hope you like it. Thumbs up. Yay. Okay. All right. Okay, so we're going to do the same thing with number 10 because most of the time people like to see more than one example of stuff. So if I do the same thing with number 10, okay, so same whole process, I'm going to take 15 and I'm going to multiply it times the n. Now I know this has got x's and y's in it. That's okay. That's not a problem. Okay. So and I'll deal with the x's and the y's. I'm going to tell you how to deal with it. I don't want you to worry about the variable part. Okay. So x squared y squared plus 7xy minus 30. Okay. So that x squared y squared, like I said, should not stress you out. It means I need an xy and an xy. That's the only thing it means. Okay, so we're good. We're just going to undo that and we're great. Factors of 30, negative 30, whose sum is positive 7. Anybody want to make a guess as to what those are? Factors of negative 30, whose sum is positive 7. Negative 30. 10. Is sneaking in there. Oh, almost. 3 divides into 30 how many times? There you go. Okay. So 3 is one of the numbers I'm looking at, but 3 divides into 30 10 times. And so I need a 10 and a 3. And the 10 needs to be positive and the 3 needs to be negative because that gives me a positive 7 at the end, right? Okay. But now I have to go back and I have to divide everything by 15, right? Yeah, because we're not done yet. I know this one's going to be incredibly messy, but it's so much nicer than the other way to do it. I think it is anyway. So this is going to simplify. I have xy minus 1/5. You do have to simplify these. 3 divides into 15 5 times. And then xy plus, and now 5 divides into both of these, and so it leaves me with 2/3. And now what do I do with that denominator? It goes back onto the front. And so my factors are 5xy minus 1 and 3xy plus 2. That is my final answer. For those of us who grew up with the guess and check method, it's actually pretty sweet to not have to do a whole lot of guessing and checking. Okay? Guessing and checking can take a while. Just saying. I'm kind of old-fashioned, still like it a little bit, but it's okay. Questions? How many more of these do we have to do? Lots. Actually, it's not lots. Let's go sit. All right. Nobody's stopping me, so we're going to keep going. Yeah. on, somebody throw that 3 in there. Okay. What did I tell you to look for on every one of these problems? The greatest common factor, right? Okay. So greatest common factor. We just didn't have one on the last ones. We talked about it. We just didn't have one. So you were just like, talking heads, go on. Okay. Somebody tell me, or lots of somebodies tell me, what is the greatest common factor? And there's 2 of them to these 3 terms. What is common? 3n, exactly. So 3n is going to factor out. And so when it factors out, it's going to leave me with an n squared minus 3n minus 460. That's a huge number. That's not a whole lot better than anything else. Okay. So now the question becomes, can I factor this further? And chances are, yeah, I can. But I need 2 factors that are relative. Now, be careful here, and let me point something out to you. You have to drag this 3n around as a factor with you for the rest of your days. I mean, it's not going anywhere. So it's part of the answer, so don't lose it, okay? Hopefully by now you're starting to get a little bit of the hang of this and know that if I have a negative number at the end, I'm going to have one positive factor and one negative factor. But I need factors of 460 that are relatively close together because the difference has to be 3, right? So here's my suggestion to you, because these can be, like, to me, super frustrating because, I mean, honestly, 460 is a big number to have to factor. So I would come over here to the side and I would say, okay, I know that 460 is 46 times 10, right? Any number that ends in a 0 has a factor of 10. But obviously, when I have negative 46 and 10, I'm not going to get negative 3 in the middle. So the difference of those is not negative 3. So now I need to look to factor something else. So I can factor 46 into 2 times 23. And so now I can stop and just kind of look at my factors. I know I'm not down to, I can factor 10 further, okay? But at this point, I would stop. And I would say, okay, is there any way I can combine these and get 2 factors whose difference is 3? Does anybody see my 2 factors of 460 whose difference is 3? Nope, that's it. Negative 23 and 20, okay? And yeah, like I said, I wish I could give you a super easy way to do this, but this is literally the way I work these problems. Is I would factor this and then I would start looking at pieces of my factors and I would say, okay, I would stop here and say, okay, well, if I do 2 times 10, I get 20. Oh, 20 and 23. If that doesn't work, then I would factor 10 again. And I would keep playing with the numbers. There is no magic formula, okay? There's just not. There's some magic apps out there, but they're illegal and immoral and unethical, so don't use them. Okay, and so this is my final answer. This is it. I can't do any more to that. Don't forget the 3n. That is part of the answer. Questions? All right. 9, y to the 9th, heaven forbid. Oh, yes, there is a greatest common factor. Anytime you see anything other than a 2 here, I would look for a greatest common factor. If it's not the case, we'll talk about what happens, but most common is. So greatest common factor here, I know I have a y to the 7th. Will 4 divide into all 3 of these terms? Yeah, it will. So 4y to the 7th is my greatest common factor. And that's going to leave me with a y squared minus 6y minus 1/32 I don't check my. I'm having technical issues, yes, one minute. So again, I get ready to factor this. Don't lose your 4y to the 7th. And this is going to factor pretty nicely. I know, big numbers. One positive one and one negative one. Doesn't matter which goes first, just matters where my numbers go. So let's look at 135. I know 5 divides into 135 because any number that ends in a 5 is divisible by 5, right? Okay, and so this is going to go 27 times. Well, yeah. 27 minus 5 is not 6. So we can factor 27, and it's 3 times 9. Any options here? Does this give us any factors that might work? And if not, yep, you got it. So negative 15 and positive 9. And if not, we could have factored 9 again. That's kind of boring. It's 9 and 9. And this does give me, and once again, it doesn't matter. I could do y minus 15 times y plus 9. Doesn't matter the order as long as the negative goes with the 15 and the positive goes with the 9. And so then here are my factors. Questions? We loving factoring yet? Don't answer that. You're not allowed to answer that. Factoring's like a little puzzle. It's like a little jigsaw puzzle. You just got to figure out how all the pieces fit together. Such the puzzle mode, I'm sorry. All right, questions. Okay, so this is the set of problems that we have to start using special formulas for, okay? So once again, I want you to notice we look for a greatest common factor. There's nothing common to s squared and 4, but there are 2 terms, okay? So with 2 terms, we had 3 options, okay? We had the difference of 2 squares. We had something that if it was a squared minus b squared, it was going to factor into a plus b times a minus b. We had the difference of cubes. We had a cubed minus b cubed, which will factor into a minus b, a squared plus ab plus b squared. We'll talk about that one in a minute. And then a cubed plus b cubed was the sum of cubes, and it factored into, and this is just from that previous page over there. We'll go back, I'll rewrite these again, don't worry, we'll see them over and over and over again, okay? What I need you to determine is what we want to factor. Is it the difference of squares or the difference of cubes? It's not the sum of cubes, right? Because there's a minus sign here. So that means it's either the difference of squares or the difference of cubes. Although last time I checked, this was a square, right? So that means that this is the difference of squares. And that's the way we're going to factor it. This is a formula. And it will always work. It's going to factor into 2 binomials, okay? This is a perfect square and this is a perfect square. So the 2 things that give me s squared are s and s. That's pretty nice. I'm always going to have 1 plus and 1 minus. It doesn't matter which one comes first and which one comes second. And then I take the square root of this number. And the square root of 4 is 2. That is my factored form. That's it, done. Okay. Number 14. Y'all's turn. Private message. Tell me what my factors are here. I can see your messages this time. And don't anybody put an X in the answer because it doesn't have X's. It's got Y's. Okay. I got a couple of answers. The rest of y'all are asleep. Okay. So it is the difference. And 9 is a perfect square. Y squared is a perfect square. And 16 is a perfect square. So I take the square root of 16 to get my 4. And so I have 4y and 4y plus and minus. And the square root of 9 is 3. And it doesn't matter what order I put them in. All right. I need somebody to tell me what the difference in 15 and 13 and 14 is. What is the difference? And I know there's different numbers, so don't tell me that. But there is a very huge difference between numbers 13 and 14 and number 15. Whatever you might see, I will not scream at you, but I am looking for one thing in particular. Yes. Yes. Anybody else got a guess? They are actually square roots. That is correct. They are actually both perfect squares. That is absolutely correct. But these were also perfect squares. What's different? What's different? You have these little books that say, what's different about this picture and this picture? I want you to tell me what's different about this one and this one. What kind of sign was between the two terms in 13 and 14? What kind of sign is between the two terms in number 15? Somebody help me out. I need a couple more folks to recognize what we got here. I had one or two. I need a couple more. What kind of sign do I have between my terms and number 15? This even just tells me you're paying attention to me. Yeah, there we go. There you go. Not watching cat videos or whatever stuff. All right. One more person popping in will be good. Okay. All right. So what's different is in both of these, I had the difference of two squares. This one, there's a sum of squares. There is absolutely, because, and it is hugely important that these are squares. These are perfect squares. There was nothing on my list for factoring the sum of two squares. Okay. There's a difference of squares, a difference of cubes, and a sum of cubes. You can't factor the sum of two squares. So we call this polynomial prime. And you can't factor it, right? So it is not factorable. You cannot factor the sum of two perfect squares. Done. Can't do it. Just doesn't work. Okay. All right, excellent. Very important that you recognize that. Okay. All right. Number 16 is a little bit of a challenge, but I think, I think we've got this. It is still a minus sign here. That's important. This is a perfect square. R plus P in parentheses is a perfect square. Okay. It's just a little bit different perfect square. So when I get ready to factor this, then my two parentheses, I'm going to have a 3 in both of them. That's kind of nice because the square root of 9 is 3. I'm going to have a plus and a minus. But what I'm going to put in the first part is R plus P. So I have R plus P is what was squared, and then plus and minus, and then the square root of 9. Okay? And that's it. There's nothing else I can do to that. Those are my factors. Okay. So I'm going to actually give you 2 minutes. And I want somebody, no, actually I want everybody to type in either I don't know how to factor this or the factors for number 17. Whatever you think might be the factors. This one is a little bit different. But I need to make sure everybody's still out there because I'm thinking I've lost some folks. We got some real important stuff left to do. You get 2 minutes. And then I'm gonna like randomly pick on somebody to call on who's not paying attention. There you go. I can deal with that answer. Ooh, we got some ideas. Ooh, we're getting some ideas. I can deal with these answers. Some of them are good, some of them are, but it's okay. I'm getting answers. Getting answers. Okay. So some of you, I'm still waiting to hear from a couple of people, but I love this one, except we're not done. So can we go further with this? Can we go further with this? Well, either one of those factor further. I told you we're not done. So that should tell you something. That one won't factor further than the other one will. At least getting out a thing like a tiny. C squared plus 1 doesn't factor. Can't factor that one. C squared minus 1 factors. It is the difference of two perfect squares. Who can tell me what factor means? You had it to begin with. What about this? Could I do a C plus 1 and a C minus 1? I think I can. Yeah, don't be confused. It's okay. It's okay. All right. So here is my final answer for this problem. So I really was very pleased to see that several of you got the C squared plus 1 and C squared minus 1, because that's kind of, to me, that's the big step there. C squared and C squared does give me C to the 4th. The minus tells me I've got, and then 1 is just, it's a perfect square, it's a perfect cube, it's a perfect whatever it needs to be, okay? The catch on this one is that I can still factor this part of this problem because this is still the difference of squares. This one, some squares, I can't do anything with it. So watch out for this kind of problem. You will see this again. This is just, I know it's in the homework and I'm pretty sure it's on the quiz. So just watch out for that kind of problem. If you do have that fourth power in here, chances are you should be able to get more than just the 2 factors, okay? So be careful. Right. Hopefully you're unconfused now. So I hope so. All right. Let's look at these couple of problems. So now I have a cube, and both of these have a perfect cube, and both of them have a perfect cube for both parts. So this one is the difference of cubes, and this one is the sum of cubes. And so I'm going to actually write this, I'm going to write it over here so that we can see what's going on. So this one is the difference of 2 perfect cubes, and this is the way this factors. It factors always with the binomial here, okay? I square this first term, it's a squared. I change this sign, so same sign, opposite sign. I multiply these 2 pieces together, and the last one is always positive and it's always squared, okay? So what I need you to recognize for me is 2 terms with a minus sign in between them. I'm going to have a and then minus the cubed root of 27 is 3. So it's a minus 3. Same sign. My sign's always going to be the same here. Okay. Now I want you to stop. And I don't want you to look at what's over here. Okay. I simply want you to look at this binomial. And I'm going to get my answer by squaring this first term. So I have a squared. I change this sign. So it's going to be plus. I multiply these 2 terms together. I like the number first, so I'm going to say 3a. And then I square this, and when I square that negative, it becomes positive. And that's it. That's all I can do. I can't do anything else with this problem. Okay, so that is my final answer. Right? If you can learn one of these 2 formulas, then the second one of the formulas kind of falls into place by itself. And I'm going to tell you how that works. So if I have the difference of cubes, it factors like this. If I have the sum of cubes, it's going to look almost exactly like this, except that I'm going to have an a plus b, and then I'm going to, again, square a, change the sign, multiply those 2 together, square the last one, and so it's going to result in a plus squared, okay? So be really, really, really careful there, because I want to make sure that you don't have to memorize anything more than you have to, okay? So my difference of cubes is exactly the same as the sum of cubes, except they have different signs. But because this last term is a square, it's always going to be positive. So when I factor this one, it's going to factor into this binomial. The cubed root of 27 is 3, and I need an r to get r cubed, plus, because it has the same sign, and the cubed root of 1 is 1. 1's such a lovely number. And so now I'm going to have a binomial times a trinomial. Square this first part, so I'm going to get 9r squared. Change the sign so I have the opposite sign. 3r times 1 is just 3r. And then the last one is this one squared. So 1 squared is just 1. Okay. So this middle term right here is these 2 together with the opposite sign. That's where I get this 3 from. And I just changed my sign. Same thing here. A times 3 gives me my 3A there. Questions? Questions, questions. Okay. So 2 more of these. This one's going to be almost identical to number 18. Okay. So I have the difference of 2 cubes. So we're going to come right down here. I'm going to have the cubed root of 8 is 2. So I need a 2x. And then it's going to have the same sign. And the cubed root of 1 is just 1. And then my binomial is going to be, I'm going to square my 2x, and I get 4x squared. I change my sign to be plus. Anybody tell me what's going to be my next term? Looking for suggestions for my next term. Squared the first term, change the sign, what goes in the middle? Yep. So 2x, right? And then the last one is going to be plus, and it's going to be 1. And that's going to be my final answer. Okay. All right. This last one, okay? For this last one, I want you to factor this one, okay? And I want you to send it to me privately in the chat. When you get it completely factored. I know it's a little bit awkward, but you got this. Yep. Building answers, I'm getting building answers. I know these little things are kind of awkward to find. you get it wrong, you can still do the answer. It's okay. I've got the first pair for you, so all you gotta do now is tell me the second part of it. Oh, well. I bet this one's a hard one. You already got it. Okay, so I'm going to help you out with this one because I think most of you, some of you I'm still waiting to hear from because I need to work in. Okay, so remember the cube root of 27 is 3, the cube root of 8 is 2, got my x and my y because I cubed those. You square this first, so I'm going to square 3x, and that's going to give me 9x squared. Change the sign. Remember, I have the opposite sign here, so this one's going to be minus, this one was plus, and I have to multiply both of these terms together. So my middle term is going to be the product of these two. And so 3 times 2 is going to be 6, and I have the x times the y, so just be really, really careful there. And then this last one is going to be the 2y squared, which is going to be 4y squared. Questions? Okay. So kind of a preview of what's to come is, and I'm telling you this because if you can go ahead and get started on this homework assignment before we come back to class tomorrow, it will be really, really helpful. Because what we're going to do to finish out this particular chapter is we're going to talk about how to solve equations using factoring. And so if you're really struggling with factoring, then when we go to solve equations, we have to factor first, then life gets worse, okay? So please make sure that, that you look at those homework problems, you practice those problems. There are, if you've seen factoring before and you're like, oh my gosh, this was what I really hated in algebra was the factoring. And while I think there's a pretty good number of homework problems on there, if you feel like you need extra practice on factoring, let me know, and I'll be glad to point them out to you. There's some great study plan problems. You can go back and do similar exercise and keep practicing these. There's just factoring. I just can't emphasize enough. Factoring is just a huge concept that you've got to be able to do. It's just we just keep using it. So, and you all get to take college algebra after this class and other things too. So, just be really cognizant of making sure you learn how to factor. Okay. It's just really huge. So, okay. All right. Any questions? All right. When you don't have questions for me, then I'm going to stop the recording here.